So in the first half of the fifth module, we discussed about the theories of failure. So for various conditions of the material or the theories of failure will come into the picture we have discussed. So in the second half of the fifth module, we are going to study about the strain energy. So when the name itself indicates the strain, what do you mean by a strain? So that generally when we discuss about the strain energy or a stress or a strain, when we compare with the stress strain curve. So the strain is nothing but change in length by original length. So this is what normally we are going to define. So here we are going to convert that strain energy. So we are going to utilize the strain energy, how the strain energy. So for a different based on for a different conditions, how we going to analyze this. So in this video, we are going to study about the introduction of the strain energy, introduction to strain energy. Then we are going to discuss briefly about the strain energy in uniaxial loading. So in the uniaxial loading, how we can able to identify the strain energy. So before going to this introduction, first basically we should know about the strain. Strain is nothing but change in length by a original length. Whenever for any load or a pressure is acting on any component or any material, because of the load, the material can able to resist. If the material cannot able to resist, automatically there will be a failure or a deformation, permanent deformation. So here also the strain is nothing but where within the elastic limit it can able to regain its shape, size or a structure. So similarly here also the energy is nothing but here what we going to do is nothing but a strain energy or what we call it as a stored energy. So in depthly we'll going to discuss in this slide. Yes, strain energy. So strain energy of a member is defined as an internal work done in deforming the body by the action of externally applied forces. Yes. So whenever we are going to apply any load on any component or any object or any machine, so some deformation will occur onto that body. Based on the resisting force, the material or object or machines can able to withstand that force and it can able to perform its functions. If the material cannot able to withstand the force which is externally the load is applied on the material, automatically there is a chance of failure. So failure is directly depends upon, again it comes into the brittle metal or a ductile material. So again we can classify based on the brittle material and a ductile material, and again based on that only the deformation will occur or the deformation will come into the picture. So here the strain, normally the strain energy what we call it as a stored energy. Stored energy, how we can able to justify it's in a stored energy is nothing but whenever you're going to apply the load, it the energy will be stored. When after releasing the load again, because of that stored energy only it can able to come back or it can able to regain its shape, size or any structure. For example, for the best example for a strain energy or what we call it as a stored energy is nothing but a shock absorbers or what we call it as a springs. See, in any vehicle when we go apply the shock absorber or when we apply the load on the shock absorber, automatically it pushes inside to the that what the shocks are there, because after releasing the load on that again it can able to regain its shape, because the energy which is stored that gives the momentum back to regain its initial place. Even on the, for example, if you take even on the springs also stored energy, because when you're going to apply it will be compressed. When you're going to release the load on the spring, automatically it will regain its shape, size and a structure. That is how what we called as an strain energy is nothing but a stored energy. Strain energy also what we called as a stored energy. So this is how, and mainly the because of the what the internal work is we cannot able to identify by manually. For example, if we want to apply a load on any material, by the naked eyes we cannot able to see what the internally what the changes can take place on the material, right? So for that what we're going to do is we're going to identify the based on the stress strain curve. See, based on the stress strain curve, the elongation or the healing or an failure, also crack propagation or a rupture, all the things can be easily able to identify the stress strain curve, right? That is how we can able to identify the whether it might be a plastic deformation or whether it might be a permanent deformation or a plastic state or an elastic state. All this can able to be identified by using that stress strain curve. So this energy is also in elastic bodies and is also known as an elastic strain energy. So elastic strain, how can we able to justify that elastic strain energy is nothing but where it can able to regain its shape or a size or a structure after the removal of the load. That is the reason what we called as an elastic strain energy. And next, strain energy is the energy absorbed by the body when strained within the elastic limit. That's what we call as an absorbed or a stored energy. See, whenever we want to release the load on this, automatically it can able to regain or it can reabsorb the stored energy, and it can able to come back to its original position within the elastic limit. So elastic limit, as you know that, so within the stress is directly proportional to strain, then automatically it will be within the elastic limit. So there will be no permanent deformation. So next one is, whenever the straining force is removed from the strain body, the body is capable of doing work. Yes, even after the removal of the strain energy or the stored energy, the straining force can able to do its work. So that is also one of the major advantages of using in the strain energy. Even it is also used in the engines whenever it is required. That energy will be utilized. Now we're going to see about the just it's a strain energy in the uniaxial loading. How we can able to identify, how we can able to find out the strain energy in the uniaxial loading. So you can able to see uniaxial just only we have taken in only one direction, biaxial means two direction. So uniaxial only we are consider an x-axis in the rectangular column. Let us consider an infinitesimal element of any dimensions as shown in the figure. So just it's for an example for to identify purpose how we can able to strain energy in how the strain energy will act in the uniaxial loading. See, nothing but normally strain is nothing but change in length by original length. So here how we going to act, how we going to identify the strain energy in an uniaxial loading. So we are going to consider as an infinital element for finite dimensions as is shown. So only a uniaxial is nothing but only we are going to consider in only one direction. That is what we are going to consider as an x. And this is the plane which is the dy plane, dz and dx. So this is the three planes which is in that only one axis we have been considered. So let the element will be subjected to the normal stress. So normal stress, which is stress is acting not particularly any load or any stress, only are the normal stress is acting, or we are only considering the normal stress. Yes. Now the forces acting on this element is, as you can able to see, dx and dy and then a dz. See, all the three forces is which is acting on this particular plane. So and dy and dz are the dyx, dy and dz are the area of an element due to the application of forces. See, when the forces is applied, for example, if this is a body, when you want to apply any forces on this, so the particular area will reflect because of the forces. Whether the material can, if the material, this material can able to resist that forces, automatically it can able to perform its function. If the material cannot able to resist the forces which is the load is acting on this particular area or this particular material, automatically deformation will come into the picture. So on the area of the element due to the application of forces, the element deformed to an amount of particular distance. So particular distance or in a particular plane which will be the deformation will takes place. So based on that, the strain which is the material in the x direction, why only the x is, we are consider only the x axis. So the strain in the material in the x direction is nothing but how we can able to identify is nothing but change in length by original length. So the change in length by original length, based on this function only we can able to identify the strain energy. So this is how we going to measure the strain energy in uniaxial. If it is in the biaxial, we want to consider as an x direction and an y direction. So because of it is uniaxial direction, only we are considered in the x direction. So this is how we can able to identify the strain energy in the uniaxial. Thank you.